السلام عليكم. أنا هشرح اللسن بتاعت work and power. طيب، احنا اتفقنا قبل كده إن ال definition of energy is the ability to do work. Okay، وقلنا إن do work دي in general means make a change، وإن احنا هنتكلم على do work دي بالتفصيل بقى النهاردة إن شاء الله. Okay، طيب if I lift this ball from this first position to the second position, it is going to gain GPE energy or gravitational potential energy. Okay, the amount of energy gained by this ball is called the work done. So work done is the energy transferred between two stores. Okay, so the energy transferred to the ball is called the work done on the ball. We've taken 4 energy transfers before: heat transfer, mechanical work done, electrical work done, and waves, or mechanical energy, electrical energy, and waves. Okay, so today we're going to study how to calculate the mechanical work done. So work is the energy transfer. This is the definition of work. It is the energy transferred or the change in energy. So if one store loses energy to another, the amount of energy transferred is called the work done. So the change in energy in this store, or how much energy is lost in this store, is the same as how much energy is gained in this store, and is called the work done. Okay? So it is equal to the energy transferred. This symbol, it is called delta symbol. It means change in energy. So W is work done, stands for work done, equals the change in energy. So this symbol means change in energy, okay? And as we know, since energy is in joules, and this means that work done is in joules also, because it is the amount of energy transferred. So work is also measured in joules. The unit of work is also joules, okay? So mechanical work done is one of the 4 types of energy transfers we've taken, and this is what we're going to study today. So mechanical work is always done by transferring energy using a force. As we've taken before, a mechanical energy or mechanical work is work done or energy transferred by means of a force. Okay, any force, not any force. If I apply a force on an object and the object moves, this means that mechanical work is being done on this object. If the object does not move, so mechanical work is not being done on this object. So mechanical working is the work done by a force in moving an object, okay? So if the object moves, work has been done on this object. If it doesn't move, even if a force is applied, so no work done. So no work is done on this object, okay? The greater the force, the greater the work done, of course, and the greater the distance, the greater the work done. So this is how we calculate the mechanical work done by a force. It is equal to the force in newtons times the distance moved. But which distance moved? It has to be in the direction of the force. The distance moved in the same direction of the force, and we'll see examples about that in a second, okay? So if we want to calculate the work done on this object, if the force applied is 2 newtons and the distance moved is 4 meters, how do we calculate it? It is 2 times 4, which is 8 joules. Okay. An object in free fall, when it falls down, it starts with some GPE. And of course, when it falls down, it loses some GPE. Okay. And why does it fall? Which force is acting on it? It is the force of the weight. So mechanical work done or mechanical work is being done on this object. Okay. So the amount of GPE, the difference in GPE between this point and this point, it would be the mechanical work done by the force of the weight. Okay, so how would we calculate it? Here, work is being done by the gravitational force, okay? So if the total height is 3 meters, and the weight of the ball is 1.5 newtons, how much is the work done on the ball? Okay, so the rule is work done equals force times distance moved in the direction of the force. The force would be the weight of the ball, which is 1.5 newtons, and the distance would be the 3 meters. So the total work done would be 4.5 joules. Okay, as we said before, a force that does not cause any displacement does not do any mechanical work. Let's solve this example. How much work done is done by this force? So the crate or the box or the wooden box is going to move 20 meters, and the force is 5 kilonewtons. How much work is done? Okay, so work done equals the force times the distance. How much is the force? It is 5 kilonewtons, and 5 kilonewtons means 5,000 newtons, and the distance is 20 meters. Okay, here we need to say, since work is in joules, force has to be in newtons and distance has to be in meters, because the meters are the standard, meters is the standard unit of length. Okay, so here we have to use meters, and of course forces in newtons. Okay, so to get joules we have to use newtons and meters. So 20 times 5,000 would be equal 100,000 joules, or 100 kilojoules. Okay, how much energy is transferred to the crate? Okay, how would you calculate the energy transferred? Okay, we just said before that energy transferred means, or the energy transferred is the work done, or the work done is the energy transferred. So we already calculated the work done. So the energy transferred would be the same value, which is 100 kilojoules. Okay, now we can solve the example in the notes, page 68. How much work does the force of the girl do in lifting the box to the top of the ramp? Okay, so the force of the girl is 200 newtons. This is the force, and it is in this direction. And the box would move from this position to this position. Okay, so it's going to move 2.5 meters in the direction. See, this is in the direction. It is parallel to the force. Okay, so how would we calculate the work done? Force times distance moved in the direction of the force, which is 200 times 2.5 meters, okay? Which will give us 500. Work done is 500 joules. Okay, the next part is how much GPE does the box, okay, or the crate lose if it is left to slide back down? So if the box starts here and it slides back down to this position, how much GPE would it lose? Okay, so this means what is the energy that will be transferred from the box, okay, or that the box will lose if it is left to slide down. And we also know that the energy transferred or lost would be equal to the work done, because the box will slide down due to the force of gravity, okay? And this is mechanical work done, so we know how to calculate it. And we know that work done equals force times distance. But in this case, which force and which distance? So now that we know the force, it will slide down because of the force of its weight, which is in this direction, okay? And it is straightforward, so the force is 400 newtons times which distance? It has to be the distance in the same direction. So the box is sliding from this position to this position. And what is the distance between these two positions? In this direction, it would be this distance. So the distance would be 0.75 meters. Okay, so this will give us 400 times 0.75. I'm sorry, I didn't calculate it. You can calculate it yourself, okay? Let's solve this example as well. A woman does work by pushing a stroller. The woman pushes the stroller with a force of 200 newtons, and the energy transferred in the stroller is equal to 200 joules. Calculate the distance. So this is very straightforward. Work done or energy transferred equals force times distance, okay, which is equals to 200 times distance. And the work done is already 200 joules, okay? So the distance would be 1 meter, okay? A woman draws a bucket out of a well. The bucket has a mass of 10 kilograms when filled with water, and the well is 15 meters deep. Calculate the energy transferred to the bucket. Energy transferred is the work done, okay? So it would be 10. To get the force, we need to calculate the weight, not the mass. We have the mass. So the weight would be 10 times 9.8, which is 98 newtons, okay? And the work done is force times distance, and distance is 15 meters, okay? So the work done would be 98 times 15, which is 1,470 joules, okay? Now you can come to power. Okay, what is power? Power is the rate at which work is done. And when we say the rate, this means that we are dividing by time. Always when we say the rate of something, means we are dividing it by time. So power is work done divided by time, okay? If two motors or if one motor lifts a load a certain height, so it's lifting this motor will lift the load this height, okay? And this motor will also lift the load the same height, but this one will do it faster. This one will do it faster, okay? So faster means more power. So both motors will lift the load for the same height. This means they are transferring the same energy. It's the same weight, so the same force and the same distance, same energy. But the one that will do it faster means it's exerting more power or giving out more power, okay, or has more power. So power means the change in energy or the work done divided by the time. This means the less the time, the more the power, okay? And power is measured in watts. If you buy a charger, a super fast charger, and you look at the rating of the super fast charger, you always find that the super fast charger has a higher watt number. So maybe the old chargers are usually 20 watts, but the super fast charger are mostly 45 or 65 watts, okay? This means that they have more power and they charge faster. They charge our phones faster, okay? That's why they have more power. Okay, let's solve the notes, page 72. A man is working on a platform. He uses a rope to raise a bag from the ground to the platform as shown in the diagram. The man then lifts a second bag from the ground to the platform. The first bag weighs 100 newtons. The second bag weighs 150 newtons. On which bag of materials does the man do more work? So he's lifting both bags the same height, but one of them is heavier. So he's exerting more force, okay? So we know that the work done equals force times distance. The distance is the same. So definitely the work will be more if the force is more. So he will exert more work, or he does more work on the second bag because it is heavier, okay? Explain your answer. You just say the man uses more force in lifting the second bag. This is all that you need to say, okay? Calculate the work done by the man on the second bag if the distance between the ground and the platform is 12 meters. Okay, so the first bag is 150 newtons. Did they give us the weight? Yes, the weight of the first bag is 150 newtons times the distance 12, so the work done would be 1,800 joules. Okay, now he lifts the second bag in 20 seconds. So what is the man's useful power as he lifts the second bag? And we know that power is work done divided time, so we just divide that by 20, which is 90 watts. Okay, thank you very much.